Hello everyone, welcome to our day 16 discussion. Today we are going to discuss about the different types of Kubernetes pods. Let's do a quick recap what we have discussed in our day 15. In our day 15 we discussed about the storage part. Okay, so the first topic which we have discussed is empty dir. This empty dir was at the pod level. The second storage which we have discussed is host path, and the host path was implemented at the host level, means the storage was coming at the host level only. The third one which we discussed is using persistent volume, then persistent volume claim, and finally mounting it to pod. And the sub part of this we discussed about the various attributes of persistent volume and the persistent volume claim and how they are connected with each other. And finally, we discussed about the storage class. What are the different types of storage class? How it is different from our persistent volume and how it is going to create the persistent volume for us. Okay. So as I have mentioned, today's agenda is to discuss about the different types of pods. Till now we have discussed, I would say, the pod. Then we discussed about the replica set. And finally, we have implemented the deployment. And then the deployment was connected to service for providing the load balancer and the other functionality. Regarding this replica set, we have a dedicated session where we discussed about how to maintain the desired pod and the current pod. Then we discussed about different types of deployment like rolling update, recreate, a blue-green deployment. In service also we had a very detailed discussions in terms of cluster IP, node port IP, load balancer and all. So today we are going to discuss about the different types of pod. Okay, the first type of pod is called as daemon set. The first type of pod is called as daemon set. Okay, so firstly we need to understand why we need a daemon set. I would say I have this one node. Okay, then this is my second node, this is my third node. Okay, node 1, node 2, and this one is my node 3. Okay, I want to make sure we have one pod which is running on this node. I would say we have this pod which is running on this node. The same one I'm good to say on node 2 also I'm good to run one pod, and here also I'm good to have one pod. What I'm trying to say here, we have 3 nodes and 3 pods are running. Okay, I would say due to increasing workload I have added new node. Okay, let me quickly change the color. The node 4. Okay, node 4, and in this node 4 I would say a new pod should be created. So to achieve this behavior, we are good to create what? We are good to create a daemon set. So it would be the responsibility of a daemon set to, I would say, to create a pod on each and every node. Okay, if my node is going to be, I would say, scale in or destructed, then my pod will also be destructed with it. It is one-to-one mapping between the pod and the node. Okay, this behavior we can achieve using creation of daemon set. The next thing which we need to understand, why we need to use daemon set. Daemon set is generally used in monitoring software. Okay, I would say if I'm using any third-party monitoring tool called as Datadog. Okay, so what is the main responsibility of Datadog? The main responsibility of the Datadog to provide each and every information of our Kubernetes cluster. And fetch the nodes information, we need to require one agent which is called as pod. And how we are going to create that pod? We are going to create that pod using daemon set. Okay, so as I have mentioned, what exactly is daemon set? So daemon set is one-to-one matching between our pods and their node. If the node is going to be increased, then our pod is also going to be increased. And if node is going to be decreased, then our pod is also going to be decreased. This is the main functionality of a daemon set. So let's do a quick demo to understand it. I have already created a cluster name called as demo-aks. Let me click on connect. I'll select the subscription, open the CMD. Subscription added. Let me copy the credential. So my cluster has been connected. So the authentication part done. We'll open a Visual Studio. In Visual Studio, I have already created dsystin folder. I'll create a YAML file name called as ds.yaml for my daemon set. And the configuration details are, if you see in this YAML configuration, we have mentioned daemon set, then the name of the pod. And here if you see, we have the selectors, app colon nginx, and then we have the template, the labels of app colon nginx, and this is the specification. Using this image, we are good to create a container ABC, and firstly it is going to select for a pod which matches to app colon nginx. If it is not present, then using this template, it is going to create the pod. What is the purpose of daemon set? I would say if I have 4 nodes, then 4 pod will be running. Okay, it is one-to-one mapping between the node and pod. Let me run this YAML configuration. We'll copy the path. And the command is kubectl create -f ds.yml. And finally, my pod has been created. I'll mention kubectl get pods. If you see here, how many pods are created? I would say 2 has been created. The third one is in creating stage. Let me run it again. If you see here, finally 3 pods have been created. Okay, let me run a command called kubectl get nodes. So currently, how many nodes we have? We have the 3 nodes. That's why 3 pods are created. I would say this is my node 1, this is my node 2, and this is my node 3. So in each node we have the pod created. Again, let me decrease the size of our nodes from 3 to 1 in our system pool, and then check if our daemon set is going to decrease the count from 3 to 1 or not. Let me click on node pools. Let me click on the 3 dots and click on a scale node pool. Right now the scale method is manual and the minimum node count is 3 and the maximum is 5. That's why the 3 nodes are running. Let me change it to manual one and the node count as 1 and click on apply. So after waiting for 2 to 3 minutes, finally my target nodes is 1 and my ready nodes is 1. Let me check the configuration in CLI. The first command I'm going to run is kubectl get nodes. So what I have done, initially 3 nodes were running. Right now only 1 node is running. Okay, whatever the concept we have discussed, so only 1 pod should be present. Let me run kubectl get pods. If you see here, currently we have only 1 daemon set pod is running, and the logic is currently we have only 1 node, that's why 1 pod is running. Let me run kubectl get ds, and here it is clearly mentioned my desired is 1 and my current is 1, and the ready is also 1, up to date is 1, available is 1, and the node selector I haven't mentioned it, and the age is 19 minutes. Okay, if I'm going to run a command called kubectl describe daemon set, and my daemon set name, if you see here in kubectl describe my daemon set, this is the name of my daemon set. Then we have the selector, then the desired number of pod schedule 1 and the current number of node schedule 1, and the pod status 1 running, 0 waiting, 0 succeeded, 0 failed, and this is the pod template which we have mentioned in our YAML configuration. And finally, you see, these are the logs for our 3 pods creation. So here comes very interesting question to understand what is the difference between the replica set and the daemon set. Okay, the replica set is basically responsible to create a new pod according to our requirement. Okay, if we are going to say I need 10 pods, then 10 pods will be created. If we are going to mention I need to scale down my pods to 5, then 5 of the pods will be destroyed. So this is the purpose of replica set. While the case of daemon set, it works on the same principle, but it is directly proportional to our nodes. Means number of nodes we are going to have is equal to number of daemon set pods is going to be created. So what is the application of daemon set? As I have mentioned, daemon set is basically used in terms of monitoring. The second one I would say in terms of logging, and the third one which I would like to say, it is generally used for the networking components. Okay, once I am going to explain the AKS part, then I would explain what are the other application of our daemon set. Okay, with this we have completed our daemon set lab. So let's understand the second types of pod. The second type of pod which we are going to discuss is sidecar container. Okay, I would say I have one pod. This is my pod 1. Okay, and I have one container inside my pod. Let me quickly change the color. Okay, I have this container name called as C1, and this container is basically responsible to connect to user, I would say connect to user, and this container is connecting to other end also to clone the code. Okay, so if there would be any kind of changes at this code, so this one it is going to clone here, and then it is going to fetch to the user end. So this container is, I would say, overloaded, means 100% of the workload is done by C1 container only. Rather than giving 100% workload to C1 container, we are good to distribute this workload into two parts. Okay, the first part, it would be the C1 container, it would be responsible to connect to the user, and the container C2, it would be responsible to clone the code. Okay, and once it is going to clone the code, it is going to share at a dedicated path using a concept of empty dir. Let me update my diagram. I would say I have created one more container called as C2, and then this container is going to be responsible to clone the code. And in terms of sharing the path, as we have discussed, it is going to use empty dir, and both the containers are going to be connected on this path. So what we have achieved in this example, the first step was we had only one container which was taking 100% of the workload, which means From the user end also, the container one was responsible, and the second part was cloning the code. In the second implementation, what we have done, we have created one more container C2, and this guy is basically responsible for the 50% workload in terms of cloning the code, and the C1 container is basically responsible for the user end. And how the C2 container is going to share the code with C1 using empty dir concept. And one more thing, and the C2 will be 100% sync with our source code. Okay, this one will be the first step. Then whatever the changes, automatically it is going to be shared in empty dir. Then third part it would be container in, and finally it is going to share with our user. Okay, so let's do a quick demo to understand the sidecar container. Create a YAML file name called as sidecar.yml. We'll paste the configuration. What we are doing, we are creating a pod. The name of my pod is sidecar pod. Okay, and here I am creating containers. The first container name is main container. The second container name is sidecar container. Okay, and here I have created one empty dir volume, and the name of my volume is my vol, and with the same name it has been mounted here, I'll say, on this specific path, and here also on this / website. Okay, and I have mentioned the restart policy never. We are going to have a detailed discussion what are the various options for our restart policy in a separate topic. What we have discussed till now, we have this pod. In this pod I have this container, main container, and I have another container called as sidecar container, and I have one empty dir, and both of them are connected, and we have mounted in main container on this path and the sidecar container as website. As I mentioned, the main container responsibility, it would be connect to user, and while the sidecar container, it would be responsibility to connect to the remote URL. And for the remote URL, it would be 100% sync. If there would be any kind of changes, it will be updated here in sidecar container, finally on this folder, and then the main container will fetch the details from here. So to achieve this one, what I have done, I have passed some arguments here. If you see, it is going to create a folder name called as website. If it is present, it is good to ignore it. Then we have mentioned the cd command, and here I have mentioned .git folder is not present, then it is going to initialize, and then finally it is going to add this git repo. Okay, and then continuously with infinite loop of using while, every 10-second interval it is going to fetch the changes and going to put inside this website. Let's apply this configuration file. Okay, I will run kubectl create -f sidecar.yaml. Finally it has been created. I will run a command called kubectl get paths. Container is creating. Let me run it again. If you see here, the sidecar -pod has been created, and both the container is in ready state and the status is running. What I'm going to do, I'm going to log in inside the container 2. Okay, the command is kubectl exec -it, my pod name, then -c, my container name. Okay, and then --sh. So currently I'm inside this container. I'll move to the path called website, and let me mention dir. And if you see here, we are able to see some folder day 1, day 10, day 2, day 3, and list goes on till day 9. Let me log in the main container too. Cd and the path is this one. Till now what we have implemented? We have implemented this pod, we have container 1, we have container 2, and we have empty dir concept. And as I have mentioned, in container 1, when I'm going on this path, I'm able to see all the folder. And in container 2 also, I would say here, when I mention dir, I'm able to see all the folder. And this part is continuously in a sync with our main GitHub URL. Okay, to check is the file is currently in sync or not, let me do some changes in the source GitHub. So this is my repo which is in sync with my container C2. I'm going to add a file name called as D2 and will commit it. Okay, so let me check inside my sidecar pod, and if you see here, we are able to see this file called D2. Let me run the same command in my main container dir and see D2, which means I'm going to do any changes in this repo, so automatically it will be updated in my C2 and C1 through mtdir. This concept is called sidecar container. So the life of our sidecar container is directly proportional to our pod life cycle. So with this we have completed our sidecar container. Let's discuss the third type of pod, which is called as jobs. The third type of pod is called as jobs. Okay, so till now we have discussed, I would say, about the replica set or daemon set or deployments. What is the main purpose of all this one is to make sure our pods are always running. Okay, which means if you're going to create a pod using a replica set, okay, and one of the pod if I'm going to delete, so automatically the replica set will create a new pod for you. The same approach it will be followed in our daemon set and in our deployments too. The another kind of pods which we have is called as jobs. As the name suggests, the life of a job is to work some specific task, and once this task is going to be completed, my job status will be completed. So if I'm going to create a pod using a job kind, then it will run, and once my task is going to be completed, then the status of my pod will be completed. And this one it is called as jobs. Let's do a quick demo to implement it. I'll mention jobs.yml. If you see in this YAML configuration, we are creating a kind of job, and the name of my job is job pod, and this is a template, and the container name is counter. It is going to print Amit, and then it is going to sleep for 10 seconds, and finally my pod will be in a completed stage. Why? Because I have created a kind job which is going to run a specific task. And finally, the restart policy is never. We have three options, I would say. The first one is option is always. The second option is never. And the third option is on failure. On failure. If I'm going to mention as always, my container is going to be restarted in every situation. Terminated with any issues like one, then also my container is going to be restarted, or if my container is going to be successfully terminated, then also it is going to be restart. While in the case of never, if my container is going to be terminated with any issues or successful completion, my container is not going to be restarted. While in the case of on failure, if my container is going to be terminated with any issues, then only my container is going to be restarted. But in the case of job, we need to apply restart policy as never. Okay, let me copy this one, the path. I'll run kubectl. create -f jobs.yml. Okay, let me run a command called kubectl get pods. If you see here, the current status of my pod is running, and right now the status of my pod is completed. Why? Because my pod created this container name called as counter. It has print Amit and it waited for 10 seconds, and then the task has been completed. That's why it is in completed stage. Let me describe the pod. kubectl describe pod, and my pod name is this one. Let me maximize the screen. Okay, the details are, the name of my pod is this one. In the namespace, we are going to have a separate discussion for the namespace. Then the start time, on which node it has been created, the labels, the IP, what is the status, it is succeeded because we have created our pod, and inside the pod we have one container, and the purpose of this container was to print Amit, and then finally it waited for 10 seconds and it has completed its task. That's why it is in succeeded status. If you see the container status, the state is terminated, and the reason for it, because it has completed its task. Okay, and the mode information is present, they started and they finished. The another type of job which we have is called as cron job. Okay, this job is basically responsible to run at any specific time. I would say cron job.yml, and let me paste the configuration here. If you see in this YAML configuration, what we have mentioned, the cron job. In the last one, we mentioned only job. Okay, here we have mentioned cron job, and here I mentioned the pod. Then have I mentioned anything which is related to schedule? The answer is no. But here I have mentioned the schedule, which means at every minute it is going to run this configuration. And in this configuration, what I have mentioned, again the same thing. It is going to print Amit, and then it is going to sleep for 5 seconds. Okay, and it is going to run for minute only. Okay, so let's do a demo for it. kubectl create -f cronjob.yaml. I'll run kubectl get pods. If you see here, our cron job pod, the status is completed and the age is 9 seconds. Let me describe this pod. kubectl describe pod, and the name is this one. The most important thing which we need to check is the state. The state is terminated and the reason is completed. Okay, let me run again the kubectl get pods. Are we able to see any new pods? The answer is no. Just wait for a minute and then see. After a minute, this first pod job is completed. Again, the second pod is created. The second pod created and it is in completed state. Again, after every 60 seconds, it is going to create one pod and then it is going to run the configuration. So this comes under the cron job configuration. So we have completed both the types of job. One is a typical job which is going to be run once. The another one which we have is cron job, which is going to run at every 60 seconds, or I would say we are good to customize it, but in this example I have customized it for every 60 seconds. Okay, let's discuss the fourth type of pod, which is called as init pod. The init pod is like our sidecar container only, but I would say this is my pod, and in this pod I have two containers. Okay, the container C1 and this one container C2, and then we are good to have our empty dir, and then this empty dir is going to be synced with our C2 and with our C1, and then this C1 is going to be our user facing. Okay, and the C2 is going to copy the code from GitHub. If you have noticed in our sidecar discussion, the second container was in 100% sync with our GitHub, but in init container this activity will be treated as one time activity only, which means it is not going to be continuously sync with our remote repo. It will be one time activity, and then this and the status of this container will be completed, and it works on the principle of job, which we have discussed in our last example. Okay, let's do a quick demo to understand it. I'll open my Visual Studio Code, and in this Visual Studio Code we'll mention init.yml. If you see in this YAML configuration, again what we are creating pod. The name of my pod is init-pod, and here I have created a volume, so the diagram it would be like this. This is my init pod, and in this init pod I have this empty dir with a name called my volume, my vol, and then I have the main container. If you see on line number 15, what I have mentioned init containers. Okay, and then in this one we are going to have the init container. We are not going to have our sidecar containers, we are going to have the init container, and rest of the things it would be same. The main functionality of using init container to sync the code from our source site only once. Okay, which means it is going to clone the repo only once. Later on, if you're going to do any changes, it is not going to be synced because container has been created on the principle of jobs. Okay, and once this job is completed, then the status of this pod will be okay. Let me run kubectl create -f init.yml. Okay, kubectl get pods. If you see here, what is the status of my pod? The status of my pod is running. Let me describe this pod. kubectl describe pod, and my pod name is init-89. As I have mentioned, there would be one pod. So in describe, this is the pod name init-pod 89. I would say init-pod 89 we have. This is the status of my pod, means this pod is in a running state. Then we have containers. The first container is init containers, and what is the state of this one? This one is terminated. I would say this is my init container, and the state of this one is terminated, and the reason behind it, it completed the task. Okay, and finally, if you see, we have our main container, means this one. We have our volume this too, and in this main container the state is running. Okay, this state is running, and the other configuration it would be the condition and the other configuration. Let me quickly check the logs. So as per our discussion, the first activity which is going to be happened, it is this one. It is going to clone, then this status will be as completed, then finally in the third step it is going to start my container. So this is the first part which the scheduler has done, then pulling the image, successfully pulled the image, then start create created container init container means this container has been created, started the container, it all makes sense. Then pulling image this one, okay, successfully pulled image for this one means it has pulled the image, created main container and started main container. If you see as per this log, what I'm trying to say, the first state it has done, this container is going to be created, and once this task has been completed, then our main container started. So with this we have completed our discussion for different types of pod. Okay, let's do a quick recap what we have discussed till now. The first type of pod which we have discussed is daemon set. The basic principle of working of daemon set is directly proportional to our node. The number of nodes we are going to have, we are going to have the same number of pod. It is used for what? It is used for the monitoring purpose, for networking and for logging purpose. The second one which we have discussed is sidecar container. Okay, the sidecar container we discussed, like we have one pod, we have two containers, and then we have the empty dir, and this one it would be user facing. So rather than 100% workload in a single container, we are going to distribute the workload in two containers. I would say C1 and C2, and C2 will be indirectly, I would say 100% time syncs with our GitHub, and then it is going to follow the empty dir concept, and finally the C1 is going to be used. The third one which we have discussed is job. So what is the main purpose of job? Job is a kind of pod which is going to run for a specific task, and once this task is completed, the status of the pod is going to be completed. Okay, then we discuss subpart of job which is called as cron job. Using cron job, this job is a one-time activity. Using cron job, we are good to run at a scheduled time. And the fourth one which we have discussed is init one. Okay, so in the init container, it follows the same concept of the sidecar container, like we are going to have two containers in a pod. Okay, and the container C1 it would be user facing, and C2 is going to fetch the information, but it would be one time activity, and C2 this side init works on the principle of job only. Okay, and once this C2 container job is going to be completed, then finally the C1 container is going to be started. So with this we have completed our discussion. So thanks a lot for watching the video.